Okay, I'm in My Labs Plus here. The homework for section 3.3, well, the reading and the homework are due this week. They're set for Thursday, well, this coming Thursday, a week from today. Since the test is due Wednesday, I'm actually going to push the due date on both the homework and the quiz for next week back to Saturday. And that way, even if the test due date gets pushed back to Thursday, the quiz and the homework is going to stay due on Saturday of next week, all right? So let's have a look a little bit at some of the basics in section 3.3, at least some of the things that I think are likely to be more difficult a little bit. So here's the opening page, just tells you need to know the stuff in 3.1 and 3.2 before you do this. Now, what it starts with is it's going to give us a list of what are called basic functions, because we're going to use these to answer a variety of questions and kind of learn some things about functions, right? So there's the first one, the constant function, the identity function. That's y equals x, a straight line, right? The next one's a square, y equals x squared, or f of x equals x squared, and then x cubed. This is the absolute value function. The next one's a square root, right? F of x equals the square root of x. Now here's the idea. There's a few more. Let me get through these. So the cube root function. So instead of the square root, we've got the 3 there in the index. We've got the cube root function, okay? Now what's going to happen here with each of these, if you want to learn some more about the function, the word explanation is a link to some more stuff, right? It gives you some points to plot, have a point chart over here. They explain the function a little bit more in words here. Down at the bottom, they'll give you the domain and the range and some stuff, okay? So there's more information about each of these functions in here. Now, the last two, the reciprocal calls the reciprocals for 1 over x. And then the one, all the others you've probably seen, but this one you probably haven't seen before, the greatest integer function. All right? So I'm going to go ahead and click on the explanation link here, and we'll talk about it for a minute. So what happens with the greatest integer function, here's the graph. It looks, the symbol for it is this thing here. Actually, we'll probably see the symbol better out here. You see that's kind of a double bracket around there, two sets of lines on either side. Anyway, so let's see the word description. F equals the greatest integer of x, that's the greatest integer function, assigns to each number in the domain the greatest integer less than or equal to that number. Okay, for example, f of minus 1.99. So what's the greatest integer that's less than negative 1.99? Well, it's negative 2. Let's try positive. What is f of positive 3.99? Well, what's the greatest integer that's less than 3.99? Well, it's 3. So what happens, you see the graph here, it's like, see, here we are at 2, right? So when x is 2, the greatest integer less than or equal to 2 is 2. And then 2.1 all the way up to, right up next to 3 but not quite there, the greatest integer for all those numbers gets you a 2, right? See, the whole little line segment is right at 2. Once you get to 3, at x equals 3, you would actually jump up, and you'd have a number here and go this way. Same again. All right? So from 1 to 2, any number from 1 to 2 is right here at 1, and then we actually get to 2, it jumps up to 2. And you get this sort of disconnected stair-step thing like this out of it. All right? So the domain then, the possible x values, is all real numbers, minus infinity to infinity. The range, you can see the y values are all just integers, right? So the range is n, or n is an integer. All right? And so they've got some other things in here to kind of help you see if x is between minus 2 and minus 1, right? So you kind of work your way through it. Now, your first thing you want to do is make sure you're familiar with all of these functions and that you understand them, because we're going to answer a lot of questions using these functions as example, right? You ask about domain and range, and is it odd, maybe is it even? They'll ask you lots of questions about these things, okay? So, and you'll learn about the terminology that way, and you'll learn more about these functions. All right. Okay, so the second objective, and really the one that gives people more trouble, is what this says right here, is analyzing piecewise defined functions. All right. So the book really here does a good job of explaining it, and I'll show you there's some video links. Here's a definition of piecewise down here. You scroll down a little bit. Functions defined by a rule that has more than one piece are called piecewise defined functions. Okay? Now, the first thing it starts with is an example of a piecewise defined function, and it's the absolute value function. Now, I'm sure everybody's seen absolute value before, but most of us have not seen it. Maybe none of us, maybe nobody's seen it this way before. This is the actual official definition, and I don't know why they don't teach this typically in high school, but they usually don't. So let's look at it. It says f of x equals the absolute value of x equals in this bracket. So x if x is greater than or equal to 0. So if x is greater than or equal to 0, that's this bit right here, then the absolute value of x equals x. If x is less than 0, then the absolute value of x equals negative x. In other words, it's the opposite of x. And this is why if you kind of put this together, you always get a positive number over 0, right? Because if x was negative, you take the opposite of it and get a positive number. So here's two different pieces, right? Now if you look at it this way, this top piece here for x is greater than or equal to 0, that is the line y equals x, right? And you look at that, that's the red part here, y equals x. But it stops, right? It stops at the origin because we only do that piece of the definition for x greater than or equal to 0, right? So x greater than or equal to 0 starts at the origin and goes to the right. And for that part, we graph the line y equals x. Then for less than 0, right, so that would be the area to the left of the origin, we graph the other piece. And this is the line y equals minus x, right? Well, y equals minus x, that's the blue piece, right? Well, that's the part of that line that is less than, that has an x less than 0. And you put both of those pieces on one graph, and it's the graph of the piecewise function. Okay? Now, let's go to the next page. They say sketch a piecewise defined function. All right, so they're going to explain to you how to do it. I just ran through that, and here we have a little animation. Okay, the book is just full of all this kind of stuff. They've really done a nice job, I think, with trying to explain things. So let's look at our function here. F of x equals, all right, it's x squared if x is less than 1, and it's 1 minus x if x is greater than or equal to 1. So if you come down here, x less than 1 starts right there and goes to the left, right? And so what you do is you get the part of y equals x squared that falls where x is less than 1. And then where x is greater than or equal to 1, you get the other function, 1 minus x, you graph that one. And both pieces are on the same graph. Okay? All right. Now what I'm going to suggest you do is you come to this point, click the animation thing, give you a little video. Because we've got kind of a video inside of a video going. Actually, I've got this video open somewhere else on here. Let's, where do I have the video? Here. All right. And what they're going to do is step by step take you through. Step by step take you through graphing this. Okay.
We start by sketching the basic function y equals x squared.
I'm going to pause that for a minute. I want you to notice something. Look at the top piece. See, it has x less than 1, and the bottom piece is if x is greater than or equal to 1. So you're going to see when they graph the top piece, they're not going to include the value or the point where x equals 1 because x equals 1 is in the bottom piece but not the top. Okay? All right. So there's not enough time left to let this run out. These videos only go about 10 minutes, 5 to 10 minutes at a time. So I think that explains all the key concepts for you for this one. Watch this video. All right, when you get done with this video, hopefully you have a better understanding of how this works. If you go on to the next page, you will see there's another analyze a piecewise function. Once you've tried this, if you can't get it or you want to check your work, here you click on that, you get a video to see the solution, okay? See how to build that solution. And you'll notice when they graph these, they tend to graph the whole graph. Like they'll graph y equals 1, they'll graph the whole thing, and they'll erase the part where that doesn't match the section, right? They'll graph y equals the cube root of x, and they'll erase the parts that don't match the mod between -1 and 0. Okay, you don't need to graph the whole thing. A lot of students do find it easier to graph the whole thing and then erase the part that they don't need. But if you can graph it, if you can graph just the part you need, then that's definitely more efficient. Okay. Then in the last step, you can click this link right here, and this will give you another question to work of the same type. Okay. All right. So that's the major ideas this time, right? You got to go through and the basic functions first. Okay. Get the definitions and the pieces and the way those all work. There'll be several questions that will ask you things about all those basic functions. Then you get here to the piecewise, and the piecewise is going to be made of either the basic functions or things that are a lot like them. Like you see this next example, the two pieces are x squared and 1 over x. Those are basic what I call basic functions, right? All three of these on here, all three pieces are what I call basic functions. The one before, of the two pieces, one was exactly a basic function, and the other one was almost. It was 1 minus x instead of being exactly one of the basic functions. It was pretty close, though. All right, that's the way this is set up. If you have any questions, as always, you've got the folks in the Emporium to help you, and you've got me to help you. You can let me know. I hope this goes well, and even more importantly, I hope you all do a good job of studying for Test 1, and everybody does well on Test 1. I'll see you in class on Thursday.